Darwish,
Yes.
the weather is so nice today.
Yeah.
The air is so breezy.
Yeah. It's so windy. Yeah. Look over there. What are they doing?
I don't know, Darwish.
Let's have a look.
Congrats, sir. You have won.
Oh, I want this.
MS88! Congrats, sir. Try again later.
Come here. What is this?
This is lucky draw that you can chance to win the motorcycles.
Wow.
So, for the first prize, you can win the LCV8.
Yes. For the second prize, you can win the LCVC.
So, for the third prize, which is number 3, you can win the Honda Dash.
And last, which is number 4, you can win the Rebel helmet. You can choose by yourself.
Wow. It seems interesting.
Yeah, I agree, Darwish.
Would you like to have a chance play with this spinning wheel?
Of course, Darwish. I want a new motorcycle.
Me too. But before that, let us calculate the probability of us to get a motorcycle that we want.
Oh,
So,
okay, Darwish.
what motorcycle do you want?
I want the LC.
LCV8.
Yes.
So, we have to calculate the probability to get number 1. So, for me, LCV6, I have to count the probability to get number 2. So, let us go and
Let's
calculate
go.
first. We will come again after this. Okay?
Okay.
Okay.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Ashraf bin Azman and I will be explaining about experimental probability. So first, before we calculate the experimental probability, we have to do a table of our experiments. So our experiment involves spinning a wheel between 4 numbers, 1, 2, 3 and 4. So here we have our outcomes, the number of times and the frequency, which totals up to 30. Basically, we spun the wheel 30 times. So here is the formula for experimental probability. It is frequency of variable outcome over total number of times. Here we have the total number of times and the frequency. So we want to calculate each of the numbers. So first, P1, we'll calculate 1 first, we'll calculate in order.
Yeah.
Equals to the frequency of our variable outcome. So we look at the table 1, our frequency is 4. So we write down 4 over total number of times, like I said before, we spun the wheel 30 times as its total. 4 over 30. That's for the probability for 1. Now we do 2. Just like for 1, you look at the table, frequency is 9 and the total is 30. P3, look at the table, we get 10 over 30. We simplify it, 1 over 3. P4, we get 7 out of 30. That's it for experimental probability. So next, we will calculate the theoretical probability of each number in the spinner. So here is the formula for theoretical probability. It is number of variable outcomes over total number of outcomes. So T1. The total number of outcome is different from the total number of times, as our total number of outcome is only 1, 2, 3 and 4. 4. And the number of favorable outcomes is the outcome we want to calculate, 1 over 4. And we do the same with the rest. We only have 1 true here, so the answer is the same, 1 over 4. Same as 3. They have 1 3 there, 1 over 4, 4 is 1 over 4. That's it for the theoretical probability of the spinner landing on each of the numbers.
Okay, so for the question D, we need to find the difference between theoretical and experimental that spinner is landing at the number 3. So for the theoretical, we just follow the formula as usual. So if we want to find the probability of 3, so the answer is 1 over 4. So for the experimental, we need to find the number of time in the table. So we just follow the formula as usual. So probability of 3 is frequency of the favorable outcome is 10 over, and the total number of time is 30. So we simplify, equal to 1 over 3. So before we finalize the answer, we need to change the answer into the percentage. So for the theoretical is 25%, and for the experimental is 30%. So that is the difference between theoretical and experimental.
So for the next question is how to not get the number 4. So I will explain the difference between theoretical and experimental. So in theory, to get number 4 in the spinning wheel is 1 over 4, and the total of the probability is 1. And we need to minus 1 over 4, we get 3 over 4 equals to 75% to not get the number 4. So experimentally, in order to get the number 4 over 30 is 7 over 30, and the total try is 30 over 30, which means 1. So we need to minus 7 over 30, and we get 23 over 30, which is equal to 77%. So the difference between experimental and theory is 2% difference to not get the number 4.
Next, I want to calculate the probability of theoretical for even number. At this bit, we got 2 and 4 for even number. The probability of 2 equal to 1 over 4, and theoretical probability for 4 equal to 1 over 4. Sum 2 and 4 equal to 1 over 4 plus 1 over 4 equal to 2 over 4. In percent, we got 50%. Next, I want to calculate the probability experimental for even number. Even number same as theoretical number, which is 2 and 4. The experimental for 2 probability experimental for 2 equal to 9 over 30, and probability experimental for 4 equal to 7 over 30. We sum these two even number, 9 plus 7 over 30 equal to 60 over 30. And in percentage, we got 53%. The difference between probability experimental and probability theoretical is 50% minus 50% equal to 3%.
So for the last question is, what is the experimental probability of us not getting number 1? So here for the number 1 probability is 4 over 30. So the total probability is 1 minus by 4 over 30, that is probability of us to get number 1. 4 over 30. Calculate, we get 26 over 30. So don't forget to change it into percentage form. We will get 87%. So this is the percentage of us for not getting number 1 while spinning the wheel. That's all.